Assalamualaikum warahmatullahi wabarakatuh, and a very good day everyone. In this video, I will share with you Chapter 4 on Test of Hypothesis, focusing on the first population parameter, which is testing a single population mean mu. Let's look at this topic's learning objectives in the next slide. This topic's learning objectives are listed as follows. At the end of learning this topic, you should be able to achieve the first learning objective, which is to identify different cases in testing a single population mean mu. As mentioned in the introduction topic, we have three cases in testing mu. Therefore, we will look at these three cases closely, and you should know which of the three cases is most appropriate to solve a particular problem related to testing a single population mean mu. Having identified the correct case, now you should be able to achieve the second learning objective, which is to choose and calculate a test statistic correctly for each of the three cases. Next, the third learning objective is, by end of this topic, you should be able to perform a statistical hypothesis test on a single population mean mu using the correct procedure step by step. The fourth learning objective is you should be able to make a statistical decision correctly, and finally, you should be able to provide a sound and practical conclusion about the population mean mu that has been statistically tested. This slide presents the three cases on testing a single population mean mu with the corresponding test statistics. The cases are explained in detail in the Statistics for Engineers textbook, pages 85 until 90. The textbook also provides 2 working examples with solutions and 3 task questions for your revision. This slide, however, provides a summary of what has been explained in the textbook. Now, what are the 3 cases and the corresponding test statistics? The cases are actually the same as what you have learned earlier in Chapter 3 on estimation. Hope you can recall Chapter 3 and try to make a connection with Chapter 4. So the first case is when the population standard deviation sigma or the population variance sigma squared is known. In this case, regardless of what the sample size n is, either small or large, the test statistic is a z-test statistic, or simply a z-test defined as x bar minus mu naught, that is the value of the population mean mu under h naught, all divided by the standard error of the sampling distribution for the mean, which is sigma over square root of the sample size n. You should notice that the formula is very much similar to the standardized Z formula you learned in Chapter 2 on sampling distribution, which is available in the statistical table, page 2. The only difference is that you need to use a mu value stated under h naught, denoted by mu naught. For the second and third cases, the population standard deviation sigma or the population variance sigma squared is unknown. In such scenario, you need to look further at the sample size, whether the sample size is large, that is, n is at least 30, or small, that is, n is less than 30. We have the second case if the sample size n is large, where we can still use a z-test defined as follows. Z-test is equal to x bar minus mu naught divided by s over the square root of the sample size n, where s is the sample standard deviation used to replace or estimate the unknown population standard deviation sigma. We have the third case, or the last case, when sigma or sigma squared is unknown and the sample size n is small. In this last case, we cannot use a z-test anymore, but instead, we should use a t-test statistic or simply a t-test defined as x bar minus mu naught, which is the value of mu stated under h naught, all divided by s over the square root of the sample size n. Again, we use an estimate for sigma, which is unknown, by S, which is the sample standard deviation. Let's look at case 1 in a little bit more detail. Remember, case 1 is when we know the value of population standard deviation sigma or the population variance sigma squared. The choice of test statistic in this case 1 is z-test statistic or simply z-test. Under this case 1, we can have 3 further choices of hypothesis test that we can perform as listed in the following table. The 3 further choices depend on the choices of hypothesis test. The first one is a two-sided alternative hypothesis test where under H1 we have mu is unequal to mu naught. Therefore, the decision rule or test criterion is reject H naught if the modulus of z-test is greater than z alpha over 2. This expression is the same as writing reject H naught if z-test is less than negative z alpha over 2 on the left, or if z-test is greater than z alpha over 2 on the right. The second choice of hypothesis test is a left-sided alternative hypothesis test where under H1 we have mu is less than mu naught. The decision rule will then be reject H naught if z-test is less than the left-sided critical value, which is the negative z alpha. And the last choice of hypothesis test is the right-sided alternative hypothesis test where under H1 we have mu is greater than mu naught. The decision rule is then reject H naught if z-test is greater than the right critical value, which is a z alpha. Notice that both left and right-sided tests make use the whole alpha, whereas for two-sided tests we use alpha over 2 on the left and alpha over 2 on the right. Please also notice that under H naught for the second and third hypothesis tests, which are the left-sided alternative hypothesis test and the right-sided alternative hypothesis test, we have equality sign under H naught. But we can also write mu being at least mu naught for a left-sided test, or mu being at most mu naught for a right-sided test. Both expressions still imply that the equality sign is still under H naught. Please also remember that statements under H naught and H1 cannot overlap. For example, you cannot have H naught mu is at least mu naught against H1 mu is greater than mu naught. Why? Because then you will have redundant hypothesis statements where H naught statement overlaps with H1 statement. Now the z-test statistic, or simply z-test, is defined as x bar, the sample mean, minus mu naught, the value of mu under H naught, all divided by the known sigma over the square root of sample size n. The formula is similar to the standardized Z formula, for sampling random variable x bar in Chapter 2 on sampling distributions, which is available in Statistical Table Booklet, page 2. Now we look at the second case in testing a single population mean mu. We can use the second case if, first, the population standard deviation sigma or the population variance sigma squared is unknown, and second, if the sample size n is large, that is, n is at least greater than 30. Under this case too, we can still use z-test as the suitable test statistic, and we can also have further 3 choices of hypothesis tests which depend on the types of hypothesis tests under H1, as listed in the following table. As you can see, the table looks exactly the same as what we had earlier in case 1. The way H0 and H1 are written, as well as how the decision rules or the test criteria are stated. These are all the same as in case 1. The difference is on the definition of z-test, which is given as follows. Here in case 2, we define z-test as x bar, the sample mean, minus mu naught, the value of mu under H0, divided by the sample standard deviation s over the square root of the sample size n. Notice that we can no longer use sigma in the z-test formula because sigma is unknown. What we should do here in case 2 is to replace or substitute the unknown sigma by its point estimate, which is the sample standard deviation denoted by S. This slide presents case 3 for testing a single mean mu, that is, when first the value of population standard deviation sigma or the population variance sigma squared is unknown, and second, the sample size n is small, that is, n is less than 30. The choice of test statistic in this case 3 is not a z-test but a t-test. Under this case 3, we can also have 3 further choices of hypothesis tests that we can perform as listed in the following table. Again, the 3 further choices of hypothesis tests depend on the choices of alternative hypothesis H1. The first one is two-sided alternative hypothesis test, where under H1 we have mu is unequal to mu naught. Therefore, the decision rule or the test criterion is reject H0 if the modulus of t-test is greater than t alpha over 2 nu. The decision rule for this two-sided test can also be expressed as follows. Reject H0 if t-test is less than negative t alpha over 2 nu on the left, or if t-test is greater than t alpha over 2 nu on the right. The notation nu is the degrees of freedom defined as the sample size n minus 1. Here, the 2 critical values on the left and on the right are both at alpha over 2, as we have a two-sided test. Now the second choice of hypothesis test is a left-sided alternative hypothesis test, where under H1 we have mu is less than mu naught. The decision rule will then be reject H0 if t-test is less than the left-sided critical value, which is the negative t alpha nu. And the last choice of hypothesis test is the right-sided alternative hypothesis test, where under H1 we have mu is greater than mu naught. The decision rule is then reject H0 if t-test is greater than the right critical value, which is t alpha nu. Notice that for a one-sided test, such as a left-sided or a right-sided test, we use the whole alpha, either on the left or on the right respectively, for the critical value, as we have a one-sided alternative hypothesis test. Now the t-test statistic, or simply the t-test, is defined as x bar, the sample mean, minus mu naught, the value of mu under h naught, all divided by the sample standard deviation s over the square root of the sample size n. Again, we use s in the denominator to replace or substitute the unknown population standard deviation sigma. After looking at the three cases closely, you should have some ideas which of the three cases will be most suitable to use when solving a particular problem related to testing a single population mean mu. This is only the first learning objective for this topic. What about the other four learning objectives? The second, the third, the fourth, and the fifth learning objectives for this topic. To achieve these four learning objectives, please watch the next video on a number of practical examples on testing a single population mean mu. Until then, thank you very much for watching. Assalamualaikum and see you again in a subsequent video.